All right, y'all. We're looking right now at the topic 11 notes. Looking at the topic 11 notes. What we're going to do is we're going to start with a quick review. This is not anything that's in your packet, but we're going to do just a quick review of some information about special right triangles. Okay, so the first thing we're going to look at is a 45, 45, 90 triangle. Now, there's a special thing about 45, 45, 90 triangles. Okay, it's a super creative name that they came up with on that one. Really clearly put a lot of effort into it. Um, the thing about 45, 45, 90 triangles is all about the relationship between the length of the sides. Okay? So, first off, both of the legs are the same. So, if one leg is given as x, that means this leg is the same exact number. Now, the other thing is the hypotenuse. The hypotenuse length is that leg length times the square root of 2. And it works out that way every single time you have a 45, 45, 90. It always works out that way. The other type of special right triangle, and this one we're going to use a whole bunch looking at today, this is what is called a 30, 60, 90 triangle. Again, clearly very creative in that all they did was name off the angles that are inside of that triangle. But the special relationship that we're going to be concerned with is the relationship between the length of the legs and the hypotenuse again. Okay, so we start with the first one. It says the short leg. If the short leg is some number, x, then the hypotenuse is double that number. Okay, the hypotenuse is twice as long as the short leg in a 30, 60, 90 triangle. The other important fact is that the longer leg, if the shorter leg is given to you, the longer leg is that number times the square root of 3. All right, that number times the square root of 3 is where we get the longer leg, okay? That information, especially the stuff about 30, 60, 90 triangles, that is what we're going to be using a good bit today. And so let's take a look. Let's take a look on your notes packet. On your notes packet, we actually start off with kind of a review of what we looked at in 11 4. In 11 4, what we talked about was this little chunk of stuff right here. That is what is called a sector. That little shaded portion on the left side is called a sector. We compared it to a slice of pizza. Okay, a sector is like a slice of pizza. And what that means for us is if we and what we did with it is if we found the area of the whole entire circle, we could multiply that times some fraction, and that would tell us the area of just that one little portion of the circle. We're going to do something kind of similar to that today, but it's going to take a little bit extra work. You'll see what's going on, okay? But we have a little bit of new vocabulary to address first, okay? Some new information. The first thing is going to be this. A line segment that connects 2 points on the circle but does not go through the center of the circle, that is what is called a chord. C-H-O-R-D. Those of y'all familiar with music, it is the same word. Obviously, it means something very different, but it's the same word, chord. That is a line that cuts through the circle, but doesn't cut through the middle. Okay, and since it doesn't cut through the middle, that means it is not a diameter. Okay, a chord is not a diameter, even though it does cut through the middle of it. All right, so a chord is a line segment that connects the 2 points but doesn't cross through the middle, so it's not a diameter. So on the picture that's on your notes packet, that little arrow is pointing to the line segment. That is a chord. Okay, the line that cuts across but doesn't go through the middle. That is a chord. What we are talking about today, what we're really ultimately trying to get to today, is this thing right in here. That area inside of that. Okay, that is what is called a segment of a circle. Okay, that is a chunk that is cut off of a circle by a chord. Okay, and so there's going to be a whole process that we do to find the area of a segment. Okay, it's a three-step process, but as you're going to see, those three steps, sometimes there's kind of a lot involved with those steps. Okay, number one, find the area of the sector. That's step number one, find the area of the sector. And we have a formula for that. It's the same formula we used in 11-4. The area of the sector is theta over 360, that central angle fraction, times pi r squared. It's the area of the whole entire circle. Okay, that's what we use in 11-4. Up next, we find the area of the triangle. And what I mean by that is when you look at this, this diagram right here, this area right here that I'm outlining, that's the triangle that I'm talking about. The triangle that's made by the two radii and the chord, that's the triangle, the area that we are not interested in. Okay? And we know that the area of a triangle, base times height divided by 2. All right? Base times height divided by 2. And then step 3, what we're going to do is we're going to subtract sector area minus triangle area. Okay, so the idea is this. What we're going to do is we're going to try and take this whole entire area. Okay, if we start off with this whole entire area right here that's outlined in blue, and then we subtract this amount that we're not interested, that's outlined in red. Okay, we don't care about that amount. We are interested only in this part on top that's shaded. That's the part that we want to see. That's what we are interested in. Okay, so what we're going to do is we find the whole thing in blue, and then we subtract it, and then we find this part of red, and that's what we take out to get what we are interested in. All right, so take a look. Actually, the first thing we're going to look at is the last problem, the last example problem in this section. Okay, the last problem that we have right here, the area of, if we're looking for the area of a segment, here's what we're going to do. First, step 1 is find the area of the sector. That means we are finding the area that I'm outlining in yellow right now. That's the area that we're going to find first. Okay? So in this case, if we're talking about theta over 360, that is going to be 90 over 360. And we can tell because we've got a little box down in the corner over here. You can tell we've got the little right angle symbol down in there. So that is going to be a 90-degree angle for theta. Also, we have the radius. The radius of this circle is 8. It's just given right there. So theta over 360 becomes 90 over 360. The r squared becomes 8 squared. 90 over 360, you know, is going to reduce down to 1/4. 8 squared is going to turn into 64. And so really what we end up with is just this. Okay? If we keep our answer in terms of pi, we do all of the other calculations, whatever multiplying and dividing we need to do with the other numbers, and we leave pi out of it, at least until the very end. So we end up with 16 pi as the area of that entire yellow outlined area right there, that whole sector. Now let's look at this triangle. Okay, when you look at this triangle, you can see that this little piece of it right down here is a length of 8. That's the radius of the circle. It's the distance from this point A all the way over to this point B over here. Okay, so here's the question. What is the distance between B right here and C up here? And the answer is this. It is also 8. And the reason we know that is because the distance between B and C is the distance between the center of the circle and the edge of the circle. It's the exact same thing. It is the radius of the circle. So when we look at that triangle alone, what I'm going to do is I'm going to highlight that triangle in blue. When we look at just the triangle, it's going to look like this. It's a right triangle with both of the legs equal to 8. So that means when we find the area of this triangle, when we find 1/2 times base times height, that's 1/2 of 8 times 8. So that means it's 1/2 of 64, which is 32. All right? So look at what we have so far. What we found over here was the area of the sector. That was the yellow outline part. And we also found the area of the triangle. That was the blue outline part in our diagram. Since we found both of those, we can subtract and get this shaded area up here that we are also interested in. Okay, that's going to be 16 pi minus 32. On your assignments, this is how the answers are going to be presented. The answers are going to be given in terms of pi and in terms of the area of the triangle, however that is given. Okay? You don't have to punch anything into the calculator. You don't have to get a decimal approximation. You don't have to adjust anything else. It's just sector area minus triangle area, and that's it. All right? So right now I want to move on up to the first problem at the top of the page, and this will actually be the last one we do. We won't be doing that middle problem, all right? So let's talk about step one. Step one is to find the area of the sector. I'm going to highlight that in yellow. Okay, we're looking for this whole entire area that I just outlined in yellow. If we're doing that, we can use the formula, just like we did in 11-4. Theta over 360 times pi r squared. In this example, theta is going to be the 120 degree angle right over here. In this example, the radius is going to be 24. That's what's given right there. All right, so that's what we do. We plug those in. 120 over 360 is going to reduce down to 1/3. 24 squared is going to turn into 576. Okay? Again, just like on the last problem, we're keeping everything in terms of pi. And if that is the case, if we're keeping it all in terms of pi, we need to multiply these other numbers first. We need to multiply the 1/3. We need to multiply the 576 and not worry about pi. Okay? So when we multiply 1/3 times 576, that's where this 192 pi comes from. Okay? That wasn't just a number that was pulled out of thin air. That was 1/3 times 576. Now then, let's talk about this triangle. Okay? This triangle, I'm going to highlight it in pink right here. Okay? That is the area of the triangle that we're going to look for in step 2. But here's the problem. Okay, we know that the area of a triangle is 1/2 base times height. But as we look at this triangle, what is the base and what is the height? And how in the world are we supposed to find them? Okay, so here's what I'm going to do. I'm going to draw this triangle down here off to the side where we can look at it just completely by itself and we don't have to worry about the rest of the diagram getting in the way. Okay, this triangle has a 120 degree angle up at the top. It's got a side length of 24 right there. And when you look at this circle, when you look at the diagram, you can tell that CB is another radius. So this part must also be 24. What we have right here is an isosceles triangle. Okay, 2 of the legs are the same, so that makes it an isosceles triangle. And since we're dealing with an isosceles triangle, that means we could take it and we could cut it in half by dropping a height. That makes right angles right there. Okay? We can cut it in half, and when we cut it in half, that makes this angle up here 60 degrees. This one up here is 60 degrees, and that makes it to where this angle and this angle have to be 30 degrees. Y'all, what we did was we turned our pink triangle, our pink outline triangle, from up over here into something that must be 2 30, 60, 90 triangles. Okay? So what we're going to do now is we're going to focus only on one of them. Okay? I'm actually going to go ahead and erase the one that's on the right. We're only going to worry about this one that's on the left for a second. Okay? Let's talk about that triangle on the left. On a 30, 60, 90 triangle, one of the things we just talked about a couple minutes ago was that there's a special particular relationship between the length of the legs and the length of the hypotenuse. Well, when we look at our triangle, the hypotenuse is 24. So that means the shorter leg has to be half of that. The shorter leg must be 12. Okay? And if the shorter leg is 12, there's another relationship between the short and long leg that tells us that the longer leg has to be 12 times square root of 3. Okay? This is where this diagram is going to come from. Okay? What we have right there is what we have all of this right here. All of that right there is half of the pink outline triangle that we had way back here at the beginning. Okay, the pink outline triangle from the beginning of our diagram, this is half of that. And I'm going to go ahead and complete the other half of it. It's going to look about like this. Okay, this one is also 24. This is also 12 square root 3. This is another 30-degree angle. Okay, y'all follow me on this one. Okay, so here's the deal. If we can find the area of just this part of the triangle, if we can find the area of just this nicely diagrammed triangle and multiply that times 2, that would give us the entire triangle that we are eventually trying to look for, right? So what we're going to do is we're going to use this base and this height in the formula and then multiply the whole thing all times 2. So we're going to have 1/2 times base times height. Okay, that's what's going on right here. That's what this is. It's 1/2 times base times height. And the ultimate goal here is to multiply that times 2 so that it will give us this triangle plus this triangle both. Okay, so that's going to give us a very convenient little setup, because whenever you multiply 2 times 1/2, well, that's just equal to 1. If you're multiplying times 1, you don't have to write that down, right? So that'll all just go away. And all we have to deal with is 12 square root 3 times 12. That's 144 square root 3. Okay? So when we look back at our diagram and our colors, this 192 pi. 192 pi was the entire sector, all outlined in yellow. The pink outline triangle, that's 144 square root 3. So all we got to do is subtract those things. All we have to do is subtract 192 pi minus 144 root 3. Now, I understand that this is a lot. Okay, this is a difficult thing to understand. These are not easy problems. You're putting together a whole lot of different knowledge from a bunch of different stuff. So, to help make up for that, I'm also making a walkthrough video of the assignment on Canvas. Okay, so if you're completely lost, don't worry about it. Okay, there will be a walkthrough and there will be lots of time to pick up on this as time goes by. Okay, that's all we're going to have for the notes today. We're not going to do that middle problem. So y'all have a good one.